Consider the function g, which has a domain of 2 to infinity mapping to the real number system, for the rule g of x equals log e of x minus 2 plus 1. For part A, we want to fully define the inverse function. So the first step to finding the inverse is to let y equal the function g of x. Therefore, we can write this as y equals log e of x minus 2 plus 1. Next, we're going to swap x and y to find the inverse. Therefore, we will have x is equal to log e of y minus 2 plus 1. The third step is to solve for y. To do that, we're going to start by subtracting 1 from both sides of the equation. Therefore, x minus 1 is equal to log e of y minus 2. Now, to get the y from outside of the log, we need to take an equivalent statement. Therefore, we will have e, the same base as the log, to the power of x minus 1 is equal to y subtract 2. And finally, we add 2 to both sides to find y by itself. Therefore, y is equal to e to the power of x minus 1 plus 2. The final thing we need to do is express this using the correct notation. And the correct notation is g inverse of x instead of y is equal to e to the power of x minus 1 plus 2. And we're going to have the domain as well for x as an element of, because when we fully define an inverse function, we need a rule and a domain. And the domain of the inverse function will be equal to the range of the original function. And the range of a log graph is simply all real numbers. So this is going to be for x as an element of negative infinity to positive infinity. So that's the fully defined inverse function for g. We can also use the CAS calculator to confirm this result. So on the CAS calculator, go into the main menu. Next, we want to type in the equation where we'd swapped x and y. So we'll put x is equal to, and in the keyboard we can choose ln for log natural, or log e, and then we're going to have y subtract 2 plus 1. Highlighting this equation, we can go interactive equation inequality solve, and this time we want to solve for y. Pressing OK, and that gives us y equals e to the power of x minus 1 plus 2, which is the same as what we found by hand. For part B, on the same set of axes, we want to sketch the graph of g of x and g inverse of x, clearly labelling any axial intercepts with their coordinates and asymptotes with their equations. Next, we can also use the CAS calculator to help us graph the function g and its inverse. So we have its inverse, and we can also drag this line or this part of the line down and replace the y with an x, and that will be the original function. So clicking on the graph icon, we can now drag the original function in, which was log e of x minus 2 plus 1, and that's that graph there. And we can also drag in the e to the power of x minus 1 plus 2, which is its inverse. And you can see that it's a reflection over the line y equals x. We can also use the calculator to help us find the intercepts of these graphs. So if we go analysis, gsolve, y-intercept to start with, we need to press the up arrow to select the other graph or the inverse graph, and hitting execute will give us the y-intercept. However, you'll notice that this isn't exact, so we need another way to find what the exact value of that is. And to find the exact value, what we can do is we can go back up into the main screen and change the x for 0. So I can go keyboard and use the straight up and down line and tell it to have x equals 0. And this is the value of the y-intercept that we'll need to put on our graph in a moment. Heading back to the graph, we can go analysis, gsolve, root, and hitting execute will find the root down here. However, that is not the exact answer, that's just a decimal approximation, so we have to find an exact answer for that. However, we know that this is just a reflection over the line y equals x, so we'll expect the answer to be e to the power of negative 1 plus 2 again. But if we did ask the calculator to find it, we would go and we would get the original equation, the log equation, and set it equal to 0, and then highlight it, interactive equation inequality solve for x, and we get x is equal to e to the power of negative 1 plus 2. So that's the exact value of the x-intercept. So now that we've seen the sketch of the graph on the CAS calculator, we now need to sketch that onto our set of axes. We now need to transfer that onto our set of axes. And one of the things the calculator didn't help us find was the asymptotes. So we have a vertical asymptote here at x equals 2, and we know that due to the x minus 2 that's in the original function of g of x. For the inverse function, this plus 2 here tells us that our asymptote, which is a horizontal asymptote this time, occurs now when g is equal to 2. For our original function g of x, it was a log graph that looked like this. And on the calculator, we found that it had an x-intercept of e to the power of negative 1 plus 2, 0. And another point that exists on this graph is the point 3, 1. And I'll leave it as a task for you to verify that that is a point on the graph. So in the blue, we've graphed g of x. And now in green, I'm going to sketch the inverse. So from our CAS calculator, we know that its graph looks like this, where this intercept here was at 0, e to the negative 1 plus 2. And if the point 3, 1 is on this graph, then 1, 3 is on the graph of the inverse because x and y has been swapped. So in the green, that is the inverse of g of x.